Hi everyone, in today's video we're going to talk about strategies to solve optimization problems. So since the video got really long, I've made part 1 and part 2. So in part 1 we're going to go through an easy and medium problem, and then in part 2 we're going to go through a really difficult question. So starting in part 1, we're starting with a relatively easy question. So question 1. You have 50 meters of fence to build a rectangular enclosure. What is the maximum possible area that you can make? So my first step I like to work with is trying to make equations. I'm going to identify what variables are here, how can I relate them in an equation, and ultimately, since I want to maximize the area, I want an equation for area that's in terms of just one other variable. So to define the variables, what we have that's changing are the length and the width of the rectangular enclosure. So I've drawn a little diagram here, and you can see I've labeled the length and the width on both sides. And we know the area equals the length times the width. So now we just need to figure out how can we get length in terms of width or width in terms of length to sub this in so the area is in terms of just one other variable. Well, we know that the perimeter is 2 times the length plus 2 times the width. And in this case it says we have 50 meters of fencing. So the perimeter is 50 meters. So now we can rearrange to isolate one of the variables. I chose to isolate length. So we get length equals 25 minus the width. So now if we sub that into the area equation, look at this. Now we have the area in terms of just the width. And so if I expand that, just to make it easier when we're finding the derivative, we get the area in terms of the width is 25 times w minus w squared. So this is the equation that we're going to be working with. So the next thing that I want to do is optimizing. So what we're going to do here, we'll find the derivative of this equation, we'll set it to 0, and then we're going to solve for width. Because when the derivative is 0, then that means the slope of the tangent is 0, so it's a horizontal line, which would match up with a local maximum or a local minimum. So to find the derivative, after applying the derivative rules, I get 25 minus 2w. Then we set that equal to 0, and then solving for w, we get 12.5 meters. And the next thing I want to do is find the domain. So first of all, are there any restrictions on the width? Well, the width has to be greater than or equal to 0 because it doesn't make sense to have a negative side length. So this gives us some restrictions. And now I'm wondering, is there also going to be an upper limit on the width? Well, actually, there could be because other variables could be impacting the width as well. So let's look at if there's any restrictions on the length. The length also has to be greater than or equal to 0 for the same reasons. And look over here, we actually have an equation that relates length and width. So length equals 25 minus the width. So if we sub that in to represent length, here's what we get as an inequality. And rearranging to get width by itself, the width has to be less than or equal to 25. So if we put both of those together, the entire domain is that the width has to be between 0 and 25 meters. So we've noticed that because the length had restrictions, it actually impacted part of the domain for the width as well. And so now we want to check the answer to make sure the answer we got actually represents the maximum area. Because like in more complicated equations, it could be you get many answers. Some of them might represent the maximum, some could represent minimums, or there could be many different values. So we want to confirm that what we got is actually the maximum area. So we're going to check this value and both sides of the domain. So when I sub these into the area equation, we notice that the largest area is when the width is 12.5. So this is correct, that makes sense. And when we subbed in the two endpoints of the domain, we got that the area is 0. And that also makes sense because those two endpoints represented when either the width or the length was 0. So therefore the area is 0 as well. So now we can conclude by relating it back to the question. So the question asks us for the maximum area, so we can say the maximum possible area of a rectangular enclosure using 50 meters of fence is 156.25 meters squared. And sometimes the question might ask you for the dimensions, so in that case you'd actually have to get this value of width, sub it into the length equation so you can figure out the length as well. And here, just for interest, I've graphed the area function. So notice that when the width is 12.5, then that corresponds to the maximum area, and the area will decrease on either side of that until we reach those endpoints of the domain, so 0 and 25. And if you were to go outside of the domain, it would represent a negative area, because then in that case, like either the width or the length would be negative. So that's why those parts are not included within the domain. Alright, so now let's do the medium difficulty question. So question 2. The bus company notices that 120 fewer people will take the bus per week if the fare goes up by 25 cents. The fare is currently $3.75 and there are 7,000 weekly bus users. What should the fare be so that the bus company makes the most money? So again, let's start by looking at what are the variables here and try to make an equation that represents the revenue, so like the money coming into the company, in terms of just one of the variables. So I'm going to say let P represent the number of weekly users because P stands for people. So that's changing because we're starting at 7,000 and then we're subtracting 120. And let F represent the fare in dollars. Again, that's changing because we're increasing the fare by 25 cents intervals. Then the next variable that might not seem as obvious is let X represent the number of 25-cent increases in the bus fare. Because yes, this is a variable. We are changing how many times that we've increased or decreased the bus fare by 25 cents. So next, I'm going to say the revenue coming into the bus company is going to equal the number of weekly users times the bus fare. That's going to represent how much money is coming into the company. So now we want to get that in terms of just one variable. Well, we can find an equation for the number of people. That's going to be 7,000 minus 120x, because x represents the number of increases in the fare. So if x is 0, we're starting at 7,000 people. Then if x is 1, we're subtracting 120 people, and so on. So that equation makes sense. Then we can make an equation for the fare. So the fare is starting at $3.75, and then we're adding 25 cents every time that we have one increase. So again, we can think about when x is 0, it makes sense. We start at $3.75. When x is 1, we go up by 25 cents, and so on. So you can think about both of these equations make logical sense. So now we can sub those in where we have P times F. We can sub in both of these equations times each other. And now we have the revenue just in terms of one variable, x. And then as in the last example, I've just expanded this so it's easier when we find the derivative. So this is the equation that we're using here. So next, let's optimize this using the same methods as we did in the last question. So finding the derivative, we get negative 60x plus 1,300. Then we set that to 0. And if we solve for x, we get x is around 21.67. So now let's try to figure out the domain. Are there any restrictions on x? Well, I've said that x cannot be a decimal because it wouldn't make sense to go up by 0.0001 cents, for example. So this is kind of debatable. You could argue that yes, it could be decimal. I'm just going to say for simplicity in this question that it cannot be a decimal. X has to be an integer value. But other than that, there aren't really any obvious restrictions on x. So let's look at if there's any restrictions on the other variables. Are there restrictions on p? Yes, there are. The number of people has to be greater than or equal to 0. So look at this. We have an equation where p is in terms of x. So let's sub that in, and if we rearrange to get x, x has to be less than or equal to 58.33. And since we just said x cannot be a decimal, then we can rewrite this as x is less than or equal to 58. And now let's check if there's any restrictions on f. Again, the fare has to be greater than or equal to 0. You cannot have a negative bus fare. So if we look, there's an equation for the fare in terms of x. So sub that in to represent f. We solve for x, and we get x is greater than or equal to negative 15. In other words, we can only have 15 25-cent decreases in price before we would reach 0, and then it wouldn't make sense to have a negative bus fare. So if we put that together, x has to be between negative 15 and 58. But the problem is, if we look at this value of x that we got, this is actually a decimal, and we just said x cannot be a decimal. So what I'm going to do is consider two different cases. So x could be 21 or x could be 22. And if we plug those into the original equation, we'll see which of these x values would actually give us more revenue. So I'm going to do that right here. I've subbed in these two x values and the endpoints of the domain into the revenue equation. So notice that the 21, 22 give pretty similar values, but actually we get slightly more money when x is 22. So this is going to be the maximum revenue. And when x is negative 15, we get $0. That makes sense because we had said at that point that the bus fare is 0. So no matter how many people are using the bus, you're not going to be making any money. And then when we said x is 58, we made a little bit of money. That's just because we had to round it. If we had subbed in that exact value of like 58.333, we would have gotten $0 because at that point there would be no more people using the bus. So now let's make a conclusion. The question actually asks us what should the fare be. It doesn't ask us what is the revenue. So we have to do a little calculation here. We have an equation for the fare in terms of x. So if we sub in x is 22, we end up getting a fare of $9.25, which is a little bit more expensive than what I would want, but I guess it helps the bus company make the most money. So we can conclude, therefore, the bus company should raise the fare to $9.25 in order to maximize their revenue. So that's all for part 1. Thank you very much for watching, and please click on the link to watch part 2 if you're interested in going through a more difficult question. Thank you.